Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem rat in a maze. So we can see here that we have to consider a rat placed at position 0, 0 in an n cross n square matrix named as maze, and the rat's goal is to reach to the destination at position n minus 1, n minus 1 matrix cell, that is the last cell. The rat can move in four possible directions: left, down, up, right. Alright, and the matrix contains only two possible values, that is 0 and 1. And 0, that is a blocked cell, and 1, which is a free cell. And our task is to find all the possible paths such that the rat can go from the first cell to the last cell. So, and it cannot revisit any previous cell. So, we just have to find all the possible paths, and if no path exists we have to return empty list, and we have to return the final resultant vector in lexicographically smallest order. All right, it means we have to return the final result vector in sorted order. All right, so if we see an example here, so I've taken an example here, the third example, which was short to explain. So I've taken the third example. This matrix is given, this maze is given, and rat is here. All right, so we can see that rat is here. All right, rat is here, and it has to go here. All right, from the cell 0 comma 0 to the cell n minus 1 comma n minus 1. Here this cell is 2 comma 2. All right, so rat's goal is to go from here to here. All right, so what are the possible paths? And it can move to only that cell which is free, that is which is 1. So we can see easily that here are just two paths. One, we can go from here to here, and another path from where rat can go is from this path. All right, this path. So there are two possible paths. So we just have to store these paths into resultant vector. So these paths are what? These paths are just I think we have to store it in the form of a string. So first path is, let's say, green path is what? Right, right, down, and then down. So right, right, down, and down. And another path, that is the yellow one, is down, down, right, right, down, down, right, right. These two paths are possible. We can see in the resultant also that two paths are possible, right, right, down, down, and down, down, right, right. But we have to return this in lexicographically smallest order, that is in the sorted order. So we can do two things. Either we sort this resultant vector, but this will take x log x time complexity, or either what we can do, a directions array which we will use to move the rat, we can travel to the direction in lexicographically smallest order. So the directions array which I can use there, I can simply use the directions array in the lexicographically order. I will explain later also. So I can store the directions lexicographically, and this will come DLRU. It means that first I will ask the rat to go into down direction. If not possible, then go in the left, then right, then up. So this way, this rat will be first checking the down direction. So it will just go to down direction, then again down, then it will check for the left and then the right. So this way, my DDRR will be stored first, and right, right, down, down directions, this green path will be stored later. by just checking the directions in alphabetical order or sorted order. So this will save my complexity also. This we can see later also how it is working. So how we can solve this? So we know that we can just use simple recursion. If we are starting, if we are at if we are at the first cell 0 comma 0, what we can do? We can just check that where we can move. So we know that if I remove these two, so we know that if we are standing at this cell 1, we have two possible cells where we can move, either this cell or this cell. So possible paths are what? If I try down direction first, so I can just simply store also down direction, that if I choose this down direction, and again from, if I'm here, let's say I have two possible options, either from the cell 0 comma 0 I can choose either the down direction or the right direction. No possible directions are there. I cannot move out of bound, or I cannot not move any other place. So we have two possible paths. We can move down and we can move right. So first I will check for the down. So I will go down. I am here now. I should delete this. I am here now. Alright. Now from this cell where I can move, I can just move to one direction, that is down. So from this down I can just move to down, and now I will append this with down. So I have reached this cell also. And yes, from this cell I can move back to the first cell also. So for that I will use a visited array also, so that I can avoid the visited cells. So I can just use a visited matrix also, that this is now visited, and now I am here. So this is also visited, and now I can move to just this direction. So now before moving I will mark this as visited, and now I am here. So from here where I can move, I can only move to right direction. So I can just move to right direction. So this will store right. Now from this right direction, this is marked. We have now we are here. So from this position, from this cell, I can just move to the last cell only. I cannot move to the 0th cell. I can move only to the right direction. So here I can only move to the right direction. So yes, this is also marked, and this visited is also marked. Now I can see that I have reached the last cell, that is n minus 1 comma n minus 1, that is here 2 comma 2. So I will store this string. I will store this string, that is ddrr. So let's say my string I am storing resultant here ddrr. All right, and now I will return here. I will return also, so that I can check for other possibilities also. So now I came again here after returning. Here I was getting another possibility, that is right. So what I will do, before moving to the right, I will mark this as visited, and I will move to the right direction. From here I will move to the right direction, and now from this right direction where I can move, I can just move from this right direction. I can just move to the right, to this cell only, because I cannot move down, I cannot move out of boundary, I cannot move backward because this was visited. So I can just move here. So now moving here right, this will be appended with right, because I have moved to the right direction. Now this is also visited. This is also visited. Now from here I can obviously move to this down direction. there is no other possible directions, not out of bound, not backwards. I can just move to this direction and I will mark this as visited also. And yes, we forgot one thing. While returning from this, I have to mark unvisited also. While returning from here, I have to mark this as unvisited also, so that we can try the possibilities also. So now we have reached here, and we have reached here by moving towards down direction. So moving towards the down direction, and now from here we can see that we can only move to this down direction. So I will append one more down direction here, and this cell is also now visited. This cell is also now visited, and we are here. So now again I can see that I have reached to the end. That is our final destination is 2 comma 2. So I will append this also. That was RRDD, and now I will try for the other possibilities. I will just return and check if I have any other branch where I have to uh, for iterate. So I have to just go back also. I will mark this unvisited also. So we can see that we don't have any other branch left in any of the cases. So we can just uh, return this resultant data structure which we are using, vector of string. So this is the answer also, DDRR, RRDD. So we can see here, there we can see here the resultant strings are already in lexicographically sorted order. Why? Because we were uh, moving to the directions in alphabetically sorted order. First D, then L, then R, then U, because these are alphabetically sorted. So that's why our resultant also will store the resultant strings in alphabetically sorted order or lexicographically sorted order. So now if I just go and implement this, it's easy. So what I was doing, first of all, I should find the size of the maze, that is maze dot size. Now what I was doing, first of all, I was having a visited matrix. So this will be what, vector of bool, and let's call it visited, and size of this will be n cross n, and initially I will mark all the cells with unvisited. Now before visiting to the first cell, I will mark this as true because I am standing at the current cell. All right, because our rat is standing at the current cell, uh, at the first cell. Now I will call the solve function, and before calling the solve function, I will just, where we will store the answer in the resultant data structure, and our string, let's say S is empty string, will be storing the directions. And now we can just call the solve function and pass the current string and the resultant data structure, obviously the maze and size n, and yes, we will not forget to send the visited array, and at last I will return the result. Now I have to just implement this solve function. So solve function, first of all, string is passing, next resultant is passing, next what we were passing, maze we were passing, next n, and this visited matrix we have to pass. All right, and I should pass everything with reference also. Here also a reference. By reference, I have to pass everything. Now, what I was checking. First of all, if let's say that if I have, let's say if I have reached the, what was our base case, that if we have reached the end cell. So initially I was at cell 0 comma 0. All right. Now here also I should pass I comma j. What is our current cell? That is I comma j. So let's say if I is equals to what, n minus 1, and j is equals to n minus 1, that is our, we are at the last cell, that I mean the rat, that rat is at the last cell. We just have to push back our string, that is s. We can push back and we can just return. All right. Now otherwise what we can do, we can we have to travel to all the directions. So what directions, I can create a direction array. We all know about the directions array. This directions array helps us to travel all the directions. So first of all, where I have to go, down. So for going down, I have to increase I, and column will be same. Next, left. So for going left, our I will be same, 0 comma minus 1 will be there. And for going to right, 0 comma 1 will be there. And for going up, minus 1 in the row, and 0 in the column. And also we have to store the strings also. So I will create a vector of character of names where I will store the names. So direction, and then L, then right, and then this will help us writing excessive if and else cases. So here I have to now, what if I'm at any current cell, I can simply check from the possible directions. That first of all I will ask that let's say I start from k is equals to 0. I will travel to all the directions. I will try all the directions. So there are total 4 directions. So plus plus k. So what will be my new, what will be uh, the direction which I am going? What will be the index of that cell? This will be old index plus the directions of k. Let's say k will be 0, 1, 2, 3. So directions of k of 0, and similarly new column will be old column plus directions of k of 1. All right. Now I have to just check that is this new cell valid or not. So for checking the validity, I will just create another function where I will check the validity. I will pass the I dash and j dash new cells, and also I will pass the visited array. or let's handle this later. We will just pass the required parameters. And now, if it is valid, if the cell which if the cell is valid, so first of all, what I will do, I will mark the cell which we are going to, I will mark that cell with as visited, as visited, and also that if I mark this as visited, and now I will call the solve function to now go and check from the next cell. So there I will passing the new I dash and j dash new cell indexes, and string s will be same. But see, if we are able to go to the next cell, so I have to store in the cell also which direction we are moving, in the string also that which direction we are moving. So from here, if we are moving to this cell, so in the string we have to store that we are moving to the right direction. So here in the string I should push back the which direction we are moving. So we can easily check that this 1 comma 0 was representing down. So if it has its index was 0, so in the direction name array it is also down is at index 0. So I can just say that s dot pushback directions name of k. So this will help us to store the directions. So here also I will pass the string as the resultant, the maze, the n, and the visited array, visit visited array. Now after returning, what I will do, I will just undo the operations and I will mark both of them as unvisited, and I will pop back the current direction also. So this way, when our recursion will try all the possible cases, our resultant data structure will be filled. Now at last I have to just write the function, is valid function. There I will be passing the new I dash and new j dash, and let's figure it out later that what parameter I have to pass. How can we check that a cell is valid or not? So if a cell is valid, it should be, I should take this new cell as I comma j also, I comma j only. So if it is valid, it should be inside the boundary. If it is valid, it should be inside the boundary. Alright, so if it is inside the boundary, I and j should be less than n, and I and j should be greater than and equal to 0. Alright, now if a cell is valid, to move, the cell's value should be equal to 1, and also the maze of I comma j should be equal to 1, and you know what, it should not be visited. Also visited of I comma j should be false, then only we can say that we can move to that cell and that cell is valid. So we can say return true, else we can just return false. So what parameters we were passing? We were passing ij, and we were also passing the maze. So we were passing the size n also, maze also we were passing. So maze. So this will be maze. And visited array we were passing. So this visited array we were also passing. And anything more? I, J, maze, visited array, nothing else. So here also I should pass here n, maze, and the visited array. Now this will, I think this should work, and let's compile and run it and check whether we are able to pass. We haven't made any mistakes. So there is a silly mistake somewhere in the directions array. 1 comma 0, 1 comma 0, 0 comma minus 1, 1 comma 0, 0 comma minus 1, 0 comma 1, and minus 1 comma 0 is there. So yes, it is saying that somewhere mistake we have done. Yes, direction array is not vector of integer, it is vector of integer. It is vector of integer. It's a 2D array. And if I run this and now check if we haven't made any mistake, and if I submit this and check if we are able to pass all the test cases or not, so we can see we have solved this problem successfully now. And if I tell you the time and space complexity, so we can see that at every cell we are trying to go to all the possible directions, that is total 4 directions. So if there are total n square cells, and at each n square cells there are total 4 possible directions we are trying. So time complexity will be 4 to the power n square. So here I am writing that time complexity is big O of 4 to the power n square, and space complexity, we can see that we are storing the resultant string. So let's say possible paths are, let's say k possible paths are there, and each possible paths in the worst case can be covering all the cells. So this should be we go of k into n into n. And yes, the recursion stack space also, in the worst case, this will be taking the n square uh, stack space. So yes, we can see that we have now solved this problem successfully. So this was all about the problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.